So the main libraries we're going to be using this week include NumPy, Pandas, Matplotlib, and Seaborn. Let's look at these in a little more detail. The details for NumPy can be found at this particular website. NumPy is Python's primary scientific package. The main data abstract that you have in NumPy is an n-dimensional array. It's actually an ND array class. The ND array can be indexed across all dimensions. Elements are the same type. Dimensions start at 0, just like everything else in Python, and you can call it by using np.array. So array is the ND array builder, the ND array constructor, but the class that's actually implemented is an ND array. NumPy is the building block for other scientific libraries and machine learning libraries we're going to use later on. Pandas, available at pandas.pydata.org, is built on top of NumPy. It includes a data abstract where you have indexed rows and named columns, kind of like a Microsoft Excel spreadsheet or a data frame in R. Pandas references this as a data frame. There's also a one-dimensional abstract called a series, where we've got indexed rows and named columns. One of the nice things about Pandas is there's lots of input and output options to work with data from all sorts of different formats. If you want to plot the output of your logic, Matplotlib offers you object-oriented and functional approaches to graphing. It has all sorts of different kinds of plots. You can do scatter plots, you can do histograms, you can do line plots. And you will have all sorts of ways that you can control the way that your graph is actually visualized, including the thickness of the lines, the marker shapes, the colors, the sizes, the labels. Built on top of Matplotlib is Seaborn. It's a data-oriented API. It provides all sorts of aggregate statistics for categorical variables. And Seaborn is actually very good for data exploration. It builds on top of the base structure of Matplotlib. Built on top of NumPy and Pandas and Matplotlib are a lot of common Python libraries for ML solutions. Let's go ahead and discuss each one of these in a little more detail. So we've got scikit-learn. It's a popular Python library for machine learning. It's built on top of NumPy, SciPy, and Matplotlib. It's open source. It implements all sorts of different algorithms for classification and regression and clustering, and offers model evaluation for them as well. And I ask you now to please review the demos for linear regression and logistics regression that I have saved under this particular course lesson. In addition to scikit-learn, we've got a PyTorch, which is another scientific Python computing package. The nice thing about PyTorch is that it's a replacement for NumPy that supports GPUs. PyTorch implements deep learning, and it supports distributed training. Then we have TensorFlow, developed at Google and then open sourced. It includes a large library of implemented machine learning algorithms, including neural networks. It has a very nice high-level tf.estimator API. And the way you present your data to TensorFlow is via a tensor. We've got Spark ML This is the Spark ecosystem scalable machine learning libraries built on top of Spark Session and Spark 2. It's interoperable with NumPy and it implements distributed implementation of many popular machine learning algorithms. And finally, in conjunction with TensorFlow, we've also got Keras, which is a new TensorFlow neural net API implemented under tf.keras. And it's easier to use than traditional TensorFlow. And what you do is you assemble layers to build models. It's a higher level abstract for neural nets. So the Python development environments that we have available to us in this course include Visual Studio. Visual Studio Code is a popular code editor. It comes with debugging capabilities for your code. There is tab completion built into it, so you'll get more familiar with your modules and functions and the arguments that they need. If you're building your own version of Visual Studio Code, you'll need to install the Python extension. But in the data science virtual machine that we're going to implement later, you'll see those actually available to you. The other Python development environment we have is Jupyter Notebooks. It's a web-based collaborative development environment. is used to program, interpret, visualize, and document your programs. And Jupyter Notebook is a convenient way to clean and transform your data.